everyone, and thank you all for joining me in this virtual talk today. I will talk about CIM and knowledge transfer, and specifically how we at Alliander try to educate teams and improve processes for more effective CIM implementation. So first a little bit about myself. I'm Ruben Haasjes from the Netherlands, but you can call me Ruben, and I have a background in computer science and philosophy. And from my educational background, I'm interested in knowledge representation and information modeling. And I was lucky to find a job that aligns with these interests at Alliander in 2019. And I'm really happy to have the opportunity today to share my experiences with CIM at Alliander with you. So first of all, why do we want to use CIM at Alliander? This is related to a problem that is commonly called vertical lineage. So what do I mean with vertical lineage? What I mean is that from top to bottom, are you able to pinpoint how your information requirements relate to the actual information in your information systems? And vice versa, from bottom to top, are you able to express what the data in your system means and how this relates to the information requirements? And more often than we would like, this is not as clear as we would like it to be. So for instance, if you go to someone from the business and ask them, how is your, where can I find this and this information on this and this data and information systems, they are not always able to tell you where the data is. And vice versa, if you ask an IT expert, what exactly does the data in your system mean, they're not always able to give a proper explanation of what the data means. So what we tried to do at Alliander for a long time was solving this issue by using data models as documentations for the information that we had in our systems. So what we would do is we would look at the data in the systems and then try to derive what does this actually mean. But the problem with this approach is that data models never went beyond being documentations. They always followed what was already in the systems. And the consequence of this was that there was never really a common semantics. There were multiple definitions of the same concept, or the same information was structured in different manners without us knowing. So what we try to do for the last years is take more of a model-driven approach, and then specifically using CIM. So we cannot get around the fact that there are existing information systems with data that we have to deal with. But what we're trying to do right now is, when an information system wants to expose data internally to other applications, or also externally to other companies or stakeholders, we publish the data conform standards, and specifically CIM. So what we do, if there is an information requirement for data exchange, we first make a specification based on CIM, and this specification is then implemented to expose the data in that way. So this sounds like a really good concept to use a CIM in order to get consistent, integratable, and a common semantics of what your data mean. But you might wonder, if we're trying to do this, what's actually holding us back just implementing this for every system that we have at Alliander? Well, there is an inherent challenge to this method that we just described, and that is, this method really depends on a small group of people. And that is because in order to fully implement the full process, you have to have domain knowledge about the electrical engineering, you need to have CIM knowledge, you need to have knowledge about how you should model stuff, and you should also have knowledge about how you can translate these models to actual artifacts that are usable within information systems, such as schemas, so that it's a database schema, for instance. And as a consequence of this, that so many knowledge is required in order to execute this process. We saw that the process from model to IT artifact within Alliander was becoming quite sloppy or slow. And what I mean with that is that sometimes teams had to wait for weeks before they could get a specification for their interface. And this made them really reluctant to actually use this standardization approach for their data publishing. So I think we can break down the challenge with this approach into 3 main points. That is, how can we embed enough domain and CIM knowledge within our organization? But also, how do we deal with all the technical knowledge that is required to execute the full process from model to schema? And lastly, how do we ensure that the full process is mature enough so that people have faith and trust that what we're doing is what they want? So today I'll present a little bit about how we tackled this problem. And for us, we did 2 main things. The first thing that we did was we built a team that is dedicated to modeling and CIM. And at the same time, we also tried to automate and streamline the overall process as much as possible. So for the first part, building a modeling team, we were lucky to already have an existing team that was doing data modeling on a daily basis. But like I said before, they were primarily creating Alliander specific semantics. So we managed to repurpose this team for instead of documenting information systems with Alliander specific semantics, making the transitions to building information models for data exchanged using standards such as CIM. And one of the first things that we did was localizing the CIM to Dutch. So for the most common concepts and structures in CIM, we try to find an appropriate Dutch equivalent. And we did this in Enterprise Architect using the alias field. And this was a good process because while localizing the CIM, we also educated and upskilled a whole team of people with knowledge about the CIM and also how you should model using the CIM. However, it was not an easy process getting to this localization. We've had so many iterations discussing various things such as naming conventions. Like what kind of casing do you use in your translation? Do you use camel casing, upper camel casing? Should you put spaces between words or do you write everything together? How do you name your relations? And also very Dutch specific things like connectivity node. Do you translate that to verbindingnode or do you use verbindingsnode? So all this kind of stuff took a lot of time. I think we spent months localizing. We're not even finished. But I do believe that localizing is definitely worth it. Because, like I said before, not only did we embed the knowledge of the CIM to a team dedicated to modeling, but at the same time we are also creating an artifact that is closer to the heart of people. So if the model is also accessible to people in Dutch, they are probably less reluctant in adapting this model, since they are more familiar and more comfortable with their own native tongue. So localizing and upscaling a team is one of the things that we did. But we're also experimenting with other ways to make CIM more accessible to a broader public. So what I still think is that CIM can still remain very daunting. And if a manager or just a developer looks at the CIM, it's just this big collection of documents or this big collection of diagrams that can be quite scary to delve into. So one of the things as a little pet project that we've been working on as well is a transformation from the CIM as UML to the CIM as an ontology represented in a knowledge representation language. And first that was the web ontology language. And the result of this is a fully translated AL version of the CIM. And you can find this on sim.puffandsemantics.com. And disclaimer, this is still very much in the prototype phase, but I do think it shows what we're trying to do really well. So we're trying to find a way to make access to the CIM more intuitive. So just have an overview of what does the concept mean and what kind of properties does it have in an easy way. And another thing that is cool about the web ontology language is that every concept has a unique identifier. For instance, an URL that you see here. And in this language, you can put different labels on the same concept. For instance, I have an English label, and I have the identifier, but I also have a label from the Enterprise Architect UML model, the GUIDs. And what you can do in the interface is just swap between these different labels. So, for instance, now my interface shows the GUID. And we could use this to publish different languages of the CIM very easily. So we could also input the Dutch version of this, or German, or whatever we want to do. Another thing that we added to this publication of CIM is an interactive search bar. So you can more easily look up concept and CIM. So, like I said, this is still very much prototype phase, and we would really like feedback on this. So if you could take a look, and if you have any suggestions, feel free to contact us. And also if you would like to work on helping us with the localization of the CIM. Okay, then on to the second point, how we can improve our CIM implementation process. So in the first part, I talked a little bit about how we succeeded pretty well in expanding CIM knowledge within Alliander. So we created a dedicated team that is now able to understand the CIM and also able to create profiles. So take a relevant subset of a CIM for a specific use case. But the question still remains how we translate these profiles to actual implementations in information systems. At Alliander, we've been working on this for quite some years. And if I look at it, I think we can divide the maturity levels, or the different stages of maturity that we went through with this process in 3 different levels. And I will go through them now. So at maturity level 1, where we're just starting out, what happened at this stage is that a CIM domain expert created a profile, and at this level this was still just creating a diagram and highlighting in Paint which classes, attributes and relations should be used. And then an IT expert by hand translated this profile to something that was usable for him, for instance a database schema. But this whole process was very error prone. There were a lot of typos, and there's still not a very good separation of concerns here, because even though the domain expert only creates a diagram, the IT expert still has to understand how to interpret this diagram in order to translate it to a correct schema. So what we did next was trying to step it up a bit, and from there on we started using a dedicated schema composer tool for creating our profiles. And there are various tools available, such as the Enterprise Architect Schema Composer, CIM Contextual, CIM Tool. We've also experimented with creating our own Schema Composer. But for now we have settled with the Enterprise Architect Schema Composer. And to be fair, it also shouldn't matter so much which schema composer tool you use. I think the most important thing here is that the meta model behind the output of the schema composer is sound. So we chose to align this closely to the upcoming IC 501, in which a profile is expressed as vocabulary using RDFS and constraints using SHACL. And we believe that this meta model for expressing profiles is expressive enough to then translate to more specific artifacts. And that's exactly what we're doing now. So from the pivot model, the profile, we automatically transform to commonly used schemas within Alliander. And for us, that is Open API specifications, JSON schema, and Avro schema for the exchange at a real-time data platform. But even at this stage, although it was a big step up from maturity level 1, we still had a lot of problems. And those were mostly metadata management problems. What we had was that schemas were often sent by email, and we had no real version control and also no real overview of created schemas. So we had no good grasp on the process surrounding the schema generation, even though the schema generation itself was automated. So in order to improve this, we set up a profile repository in maturity level 3, and that's also the stage where we're currently at. We implemented a CI/CD process, a manifest for creating schemas, and a schema repository. And in practice, this looks like this. We have a GitHub repository in which we put all our profiles, and this is also where the version control of our profiles is. And every time a new profile is added or a change is made in a profile, a CI/CD process is automatically started, and this CI/CD process looks at the profiles and then looks which artifacts do I need to generate from these profiles. It then generates all the schemas that it has to generate, and these are automatically published and made available in a schema repository, and that is Nexus within Alliander. And as you can see, Nexus, we also have all the different versions of the iterations of the schema. You can also always take the latest one, and you can see all the different formats that are available. So developers can now directly take the artifacts from the schema repository. And let me delve a little bit further into the practice with a success story. So one time we made a profile for the exchange of data about fault current detections, and this dataset was originally published on a real-time data platform. And like I said, we use Avro schema for that, to serialize and deserialize the information. But later, a couple months later, the manager of the team came to us and was like, okay, I published it on the real-time data platform, but I would also like to publish this data as an API. And the good thing about this whole process is that within 5 minutes, we just only had to change that, okay, also generate an Open API specification. The Open API specification was available as a blueprint for the team. And that relates to the last thing that I want to discuss today, and that is the different usages of the artifacts that are being generated. So like I said in the example, the first usage is that it's being used as a blueprint. So they take the artifact, and from there they generate some code that is the starting point for their data exchange. And a second way in which these artifacts are used within Alliander is data validation. So the schemas can also be used, for instance, JSON schema, to validate if the data that you are publishing conforms to the schema that you have specified. And lastly, and that's also where I started with, it completes the vertical lineage. So what we do is we try to always refer back to the model and the classes that we used to create the schema. So an artifact, for instance, an Avro schema, contains a link to a diagram in which we explain, okay, these are the classes that we use and these are the attributes that we use. So from the data, it's immediately clear what does the data mean. Okay, now to wrap up. Today I talked about how if you want to efficiently implement CIM, it requires both CIM modeling knowledge and technical knowledge. But on top of that, you also need mature business processes to make people believe in this model-driven approach. And I think what's important in creating of improving the maturity of this process is that you have a good separation of your tasks or concerns. So what we did is we built a dedicated team in which we embedded the knowledge of CIM and modeling, and we automated as much as possible to manage and streamline the process from this model to usable artifacts within our information system. Yeah, and although it's not fully integrated yet in Alliander, I believe we made some great progress in expanding our CIM knowledge in our organization and also improving the efficiency of the CIM implementation in general. So that's it from me from today. Thank you for your attention, and I'd be happy to answer any questions if you have them.
Thank you so much for watching. I hope you found this video insightful and enjoyable. We post new smart grid related videos every Friday at 12 CET, so please go ahead and subscribe and let colleagues in other departments and peers in other organizations know so that they can benefit too. We welcome your feedback, so if you have any comments or questions, please feel free to post them below. Thanks again and have a great day.